Designing a database for a train booking system is a great way to practice your database skills. It's a concept you're likely familiar with and has a bit of complexity that needs to be considered. In this video, I'll show you step by step how I would design a database for a train booking system by going through a set of requirements and creating a diagram. I've come up with 10 requirements for this fictional train booking system. We'll add each of these to an entity relationship diagram to represent our database. Requirement number 1 is about the train. A train starts at a train station, ends at a train station, and can stop at different train stations along its journey. Here is an empty diagram in my preferred diagramming tool, Lucidchart. How can we capture this requirement? First, we add a table for a train station. We'll give it an ID for its primary key, which you'll find I do for most tables. What else do we want to capture for a station? We have a name, so I'll add a column called station name. The requirement also mentioned a train, which I think represents a journey, where you start in one place and finish in another. So we'll add a new table called train journey with an ID column. I'm not sure what else we need to store for this table, but that's okay for now. We may learn more later about this table. So how are these two tables related? Can a train journey have multiple stations? Yes, we saw that in the requirement. Can a station have multiple train journeys? We're not sure yet, but we could assume that yes, it can, because we're building a train reservation system. We can change it later if we're wrong. This is a many-to-many relationship, so we'll need a joining table. I'll add a table in the middle called Journey Station, which contains the journey ID and the station ID as foreign keys. It will have a record for each of the stations that a train visits. How do we know what order the train stops at each station? It would be good to store some kind of order of stops. Let's do that now. We'll add a new column called Stop Order, which stores a number to identify the order. This design meets our first requirement. Let's see what's next. If you think this video is helpful, then you'll enjoy the bonus I've prepared for it. It's a PDF that contains the final entity relationship diagram, a written explanation of each of the tables and fields, and SQL scripts to create these tables in a database. You can get your copy by visiting databasestar.com/dbtrain. There's a link in the description for this as well. Let's get back to the diagram. Requirement number 2 is about timing. A train journey has a planned start time and times for each station on its journey. Multiple trains can run on the same day. We assumed this was the case, so it's good to see it here. How do we add this concept of a planned start time and times for each station to our diagram? If we think about the planned start time, it's the time that a train leaves a particular station. We also have times for each station on the journey, which is the same thing. So we need to capture the time that a train leaves a station. We can do this by adding a departure time column to the journey station table. This will capture a departure time for each train and for each station it visits. Our requirement is met. Requirement 3 says the times for trains are not the same every day. For example, on weekends, the trains run less frequently. Let's check our diagram. How can we capture this? We'll need to have some way of recording whether a train journey is for a weekday or a weekend. First of all, what is a train journey? How do we describe it? Let's say, for our system, a train journey can be the name of a journey at a particular time. So one journey may be called the 9 AM train from New York to Boston. Let's add a name field to the train journey table to capture this. We'll need a way to determine if this journey is the weekend one or the weekday one or some other schedule. Rather than putting it in the name, we should have a lookup table for this, because there are a defined list of values. So we'll create another table called schedule with an ID and a name. This name would have values such as weekday or weekend. We then add a foreign key to the train journey table for this. Now, I think we've met our requirement. Different train journey records are created for weekday and weekend schedules, and each of them would have different times. Requirement 4 says each train journey has a train with several carriages. These carriages can have different classes such as first, second, or economy. So we've got a concept of classes such as first, second, and economy. Let's create a table for these called carriage class. We'll give it an ID and a class name to store the values such as first or economy. How do we relate this to our train journey table? Our requirement said that each train journey can have several carriages, and each of them can be a different class. So we need a way to capture these carriages for a journey. We'll add a table called Journey Carriage to capture each carriage. We have a journey ID and a position that we can use to store where in the overall train the carriage sits. For example, the first carriage could be number 1, and the next one is 2, and so on. We can add a foreign key called Carriage Class ID, which refers to the class table, and it records the class for this particular carriage. This allows us to record multiple carriages for each train journey, and record the class of each. These 2 new tables mean we have met requirement number 4. Only 6 more to go. Requirement 5 says each class of carriage has a specific number of seats which defines the capacity of passengers. Let's see our diagram. We need to capture the capacity for a carriage. How is this determined? Our requirement said that each class of carriage has a number of seats. So first class carriages may have 20 seats, second class may have 40, and economy may have 50. We can capture this by adding a seating capacity column to the carriage class table. This would store the number of seats. We can find out the capacity of a train journey by adding up this seating capacity value for all of the carriages on the train. Requirement 5 is now met. Requirement 6 says that each class of carriage has a different price for booking a ticket on the train, and there is one price for weekdays and one for weekends. So the price of a ticket is determined by the class of the carriage and whether it's on a weekday or a weekend. We've got a class in the carriage class table. The other component that determines the price is whether it's a weekday or weekend, which is the schedule table. So we can create a new table to store the price, which links to the class and the schedule. Why don't we just add it to an existing table? If we add it to the train journey table, it won't capture prices for different classes. If we add it to the class table, it won't capture prices for weekend versus weekday. We could add it to the journey carriage table, but this would mean we can have different prices for the same class and schedule, which is not what we want. So we create a new table here. I'll call it carriage price. I'll add the foreign keys for the schedule and the carriage class, and then add a price column. Requirement 6 is now met. Requirement 7 is about passengers and how they book train tickets. They specify a few things such as date, stations, the class, and they are shown the price and then create a booking. Let's see our diagram. I think we'll need a new table because we're capturing an event of something happening and there are a few things being stored. We'll call it booking. We'll give it an ID column. What do we need to store? We'll store the date of the booking, which is the date that the passenger is getting on the train. We want to capture the journey, which is the specific journey they want to get. We store the starting station and the ending station, both as foreign keys to the train station table. We also store the class of the ticket they want to book, such as first, second, or economy. This is also a foreign key. Finally, we want to store the amount they paid for a ticket. We already have the price of a train ticket stored in the carriage price table, but this will capture what a person paid at a point in time. If a price for a train ticket changes in the future, this value will be unchanged, but the value in the carriage price table will be updated. So with this booking table created, our requirement is met. 3 more to go. Requirement number 8 is about the train ticket. A train ticket has the details that the customer specified during the booking, along with a ticket number and their seat on the carriage. We could add a new table for the train ticket, but a train ticket seems to be similar to a booking, and it's something that is printed or generated based on this information. So we could achieve this by adding a few fields to the booking table, which would be included on any generated ticket. We'll add a ticket number to the booking table, which can be generated by the application or the database. We'll also add a seat number. This can be determined by the application as well, and there are queries that can be written to find the vacant seats when a booking is being made. So requirement 8 is now met. Requirement 9 is about details we want to capture for the passenger, such as name, email address, and password. We don't have anything for the passenger yet, so let's make a table. After we add an ID, we'll add both a first name and last name column. We add an email address and a password. The password will need to be encrypted and stored in a secure way, but this diagram just shows where it is stored. Does a passenger have 1 or more bookings? They can have multiple. Does a booking have multiple passengers? Not for this requirement. A future enhancement could be to book for multiple passengers, but for now it's only 1. So we have a one-to-many relationship. we'll add a passenger ID into the booking table as our foreign key. Our requirement is now met. Let's see the last requirement. Our last requirement is about passengers who are able to view their booking status and cancel it if they want. Let's see how we do this on our diagram. The requirement mentions the status of a booking. There could be a few different values. One could be a normal booking, which could be active or whatever we want to call it. Another one is cancelled, which is when a passenger wants to cancel their booking. How do we record this in our design? We need to add a status to the booking table. However, because there is a set list of values, we should do this using a lookup table. I'll add a new table called booking status with an ID and a name. The name represents the values such as active or cancelled. Then we add a status ID into the booking table as a foreign key to indicate which of those statuses apply to this booking. The ability to view the status and cancel a booking can be done within the application. So our requirement is now met. This is our final diagram, which meets all of the requirements we specified. There's a booking table with references to many other tables. We've got information about train journeys and the stations they stop at. We also have different classes of carriages in this carriage class table, and much more. Just a reminder, if you think this video is helpful, then you'll enjoy the bonus PDF I've prepared for it. It's a PDF that contains the final entity relationship diagram, a written explanation of each of the tables and fields, and SQL scripts to create these tables in a database. You can get your copy by visiting databasestar.com/dbtrain. There's a link in the description for this as well. If you wanted to enhance this diagram, there are a few things it does not include. It doesn't include the concept of a route or a train line. Train lines in cities are often a collection of stations and are often named based on colours, letters, or the final destination of the train. It also doesn't allow passengers to book for multiple people at a time, so that's something that could be added to this design. If you have any other ideas on how the design could be improved, let me know in the comments below. If you want more examples of database design, check out this video here for an example of designing a database for a real estate company. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you like this video, consider subscribing to my channel. Thanks for watching.